Hello, and today's purpose of the day is I can identify and use inverse variation. First, let's review direct variation. Remember, direct variation are equations in the form of y equals kx, where k cannot be equal to 0. This looks like, from what we know, y equals mx, right? Just without plus b, without a y-intercept here. And remember, k is the constant of variation, which in other words means the slope. So let's look at a few examples. Suppose y varies directly as x, and y equals 72 when x equals 8. The first part of what we need to solve is writing a direct variation equation that relates x and y. So remember, these equations are in the form of y equals k times x. So how would we start this problem? You got it. Plug in everything that we know into y equals kx. We know y is 72 and we know x is 8, which means we need to solve for k and then put it all together and write our equation. So I would write 72, so that goes in for y, equals k times 8. And now if we solve for k, we just need to divide by 8. So k equals 9, and if I put it all together, I get y equals 9x. So that's the direct variation equation that relates x and y when y is 72 and x equals 8. Part B says use the direct variation equation to find x when y equals 63. So now we know that y is 63 and we know that k is still 9, so we need to solve for x. So we just plug in the values that we know, solve for x, so I will divide by 9, so I get x equals 7. Simple as that. Now let's look at inverse variation. Inverse variation states that y varies inversely as x if there is some non-zero constant k such that y equals k over x or xy equals k, where x cannot equal 0 and y cannot equal 0. So let's look at y equals k over x, and let's look at xy equals k. So those are two different equations that essentially mean the same thing. You could use either equation to write an inverse variation equation. In inverse variation, the product of two values remains constant. K is the constant of variation or proportionality, and as one quantity increases, the other decreases as long as k is greater than 0. The specific two that we will review quite a bit are the first and third. Okay, so let's determine whether each table or equation represents an inverse or direct variation and explain. So let's make sure we remember that inverse variation can be y equals k divided by x or xy equals k. And direct variation is in the form of y equals kx. And when we explain our answer, that will be explained by writing an equation. So we won't even need words to explain. We will explain by writing an equation in either an inverse variation form or a direct variation form. Okay, so let's look at table 1. I see in the x values 6, 8, 10, and in the y values 3, 4, and 5. So if we think back to those inverse variation terms that we wrote down in those bulleted points in the last slide, as one quantity increases, the other decreases as long as k is greater than 0. So let's look at our table. The x values are all increasing by 2, right? Plus 2, plus 2. But now what's happening in our y values, we are also adding 1. So as one quantity, like our x values, as they increase, our y values should be decreasing. And that is not the case here, so it really can't be inverse variation. So let's look then at direct variation. We know that x and y have to relate directly, so there has to be some constant that is happening to y or to x that allows it to get the output y. So when y is 3, x is 6. When y is 4, x is 8. When y is 5, x is 10. So as you can see, we are doubling all of the y values to get to x, or simply with the x values, we are dividing them in half. So this would actually be direct variation, and a way that we could explain this, again, would be with writing an equation. So y equals something times x. So here we have to figure out what's happening to our x values to get to y. Well, if I start with 6, I end up with 3. So I'm cutting, our x values in half. So this would be a constant of 1/2. So my equation would be y equals 1/2 x. Now, a way we could check this is let's plug in a point, right? And if we didn't know that it was just 1/2 to begin with, we could test this with a point. So if I were to plug in 3, that equals k times 6, right? Because 3 is y, 6 is x, so I could divide by 6, and that's how I got 1/2 for k. But this one was simple enough that, we could tell just by looking at it. But now if I were to plug in any other point, I should get, its output for y. So if I were to plug in, x when x is 8, 1/2 of 8, is that equal to 4? It is, so then we know that our equation is correct. Okay, let's look at table number 2. So again, if we can review those facts about inverse variation, let's look at our table. So x is 1, 2, and 3, y is 12, 6, and 4. So we want to relate x and y, so let's first test out and see that, as one quantity increases, does the other decrease? So my x values are going up by 1 each time, so those are increasing. And what's happening to my y values? Well, they're going from 12 to 6 to 4, so it does decrease. So we're thinking this would most likely be inverse variation. Now, the next thing we need to look at, and we didn't check this on the first table because it did, as one of those, values increased, x or y, did the other decrease? No, it didn't happen. So we knew, therefore, table 1 was direct variation. But in this case, as the x values increase, the y values are decreasing. Again, we went from 1, 2, and 3, so the x values were increasing, to 12, 6, and 4 in the y values, and those are decreasing. So then let's look at an inverse variation. Does the product of two values remain constant? Which means x times y should always give us the same output no matter which pairs that we choose. So 1 times 12 here equals 12. 2 times 6 here also equals 12. And 3 times 4 equals 12, not 13. So all of the values multiplied together give us the same constant. So therefore, now we know we have inverse variation. So now if I wanted to write an equation, I can either choose, again, right up here, y equals k over x, or xy equals k. So here, we know that x times y equals what constant? Well, we got 12 for each one. So I could say, this is inverse variation. And I could write, because xy equals 12, that's what our two terms multiply to be, that constant of 12. Or I could write y equals 12 divided by x, and that would be the same equation. Again, because my constant is k, so that would be in the numerator. So that would be my answer for number 2. Okay, number 3 is in the form of an equation. So as we look at number 3, we see negative 2xy equals 20. Well, this is almost already in the inverse variation form of xy equals k, except that we have that negative 2 in the way. So let's just get rid of it. Let's divide by it to get rid of it, to isolate x and y. And I get xy equals negative 10, and now we are directly in the inverse variation form. So I would write inverse, and the way to explain would be by writing the equation xy equals negative 10. Number 4, x equals 0.5y. Which one of the forms does this look like? Does this look like direct variation, y equals kx, or inverse, which would be xy equals k, or again, y equals k over x? Well, this looks more so like y equals kx, but the x and y are just flip-flopped positions. So let's move the 0.5 over, and let's get y by itself and have that constant being multiplied with x. So what I can rewrite this as to make this easier is x equals maybe 1/2 y. And now if I multiply by the reciprocal, I can get rid of that fraction here and get y by itself. So I have to multiply by 2 over 1 here. So 2 over 1 times x is 2x. So I would write here for my answer, direct variation, because y equals 2x. And that's the, equation for direct variation. So that's why our answer is direct. Now we are going to go through a couple examples of where we are solving for a variable if we have inverse variation. So we're going to look at what's called the product rule for inverse variations, and there's two different product rules that you can use that you feel most comfortable with. So in words, what is happening is if we have two ordered pairs and they are solutions of an inverse variation, then the products of both of those ordered pairs will be equal, which we've already looked at. In symbols, you can see that x sub 1 and y sub 1 multiplied together have to equal x sub 2 times y sub 2. Again, their constants have to be the same when you multiply those ordered pairs together. Or we could write a proportion, which would be, our first x term over our second x term. That's got to be equal to our second y term over our first y term. So x sub 1 over x sub 2, that's got to be equal to y sub 2 over y sub 1. So we'll look at two different examples, and you can see which one you like better. All right, so solving for a variable. Assume that y varies inversely as x. So if y equals 5 when x equals 12, find x when y equals 15. So let's look at method 1, the product rule. So method 1 of the product rule says x sub 1 times y sub 1 equals x sub 2 times y sub 2. So right now let's go back and let's give a label to each of our y's and x's in those numbers so we know exactly what we're going to plug in. So if y equals 5, we'll call this y sub 1. When x equals 12, we'll call that x sub 1. Find x, so that's x sub 2, when y equals 15, and that would be y sub 2. So now let's plug these into our product rule. So I have x sub 1 is 12 times our y sub 1, which is 5, and that's got to be equal to x sub 2 times 15. Now 12 times 5 is 60, equals 15 times x sub 2, divided by 15. 60 divided by 15 is 4, so here x sub 2 would equal 4. Or we could use method 2, which is setting up a proportion. So this is saying x sub 1 over x sub 2 has to be equal to y sub 2 over y sub 1. Now we can solve for x sub 2 this way, and we should get the same answer. So I would say x sub 1 is 12 over x sub 2, which is our unknown, and that's equal to 15 over 5. Here we can look at cross products, so we can multiply these terms, and 12 times 5 has got to be equal to 15 times x sub 2, which is right what we were at up here, right? So we have 60 equal to 15 times x sub 2. And now I divide by 15, and I get 4 equals x sub 2, which was the same answer we had right there. So we are happy. So feel free to use any method you would like when you have inverse variation and you have to solve for an unknown variable. Thanks for watching. I hope you have a great day. Please check Google Classroom for more information. Bye-bye.